Welcome students, welcome to today's lecture. Today is the fourth lecture of our vector integration series. Now today we shall discuss about surface integrals. This is the most simplest form of any surface integral. Now in line integrals we have to deal with one variable, and in case of surface integrals we have to deal with these two variables. Since there are two variables, so there are two integrations. That's why this type of integrations are somehow called double integration. You have to decide whether you will do the x part first or y part first. Actually, there is no hard and fast rule that you have to do the x part first or the y part first, but you have to decide, because in every mathematics the limit is not so easy. See, this is two independent limits, x from 0 to 1 and y from 0 to 2. Sometimes in surface integrals these limits may be dependent upon each other. Later we shall see about that. And now for this simplest surface integral there are two methods. For the first one, I have done first the x integration, then the y. The second bracket indicates that first only the x integration will take place, keeping y constant. So x square becomes x cube by 3. This x becomes x square by 2, keeping y square constant. And when I will put the limit 0 to 1, only the x will change. So we can put 1 here, 1 cube, that is 1 by 3. Here also 1 square equals to 1, so 3y square by 2. Minus, put 0 in everything and everything becomes 0. So now we have only y parts. Remember one thing, if you do any type of mistake in this type of integrals, then the y part will contain any x or x variable. Suppose you have made any type of mistake and you are left with x by 3 plus 3y square by 2 dy, then this is wrong. This is the last integration and only the last variable should prevail. So if something happened, then you can recheck your mathematics. This is the proper way to check whether you are doing right or wrong. Now see, there is only a constant part and y part, so I have done the right way. Now this is become y by 3 and this become y cube by 3. So 3 cancels out and the remaining part is y cube by 2. After putting the limit we have 14 by 3. Now what happened if the y integration will be carried out first and then the x, like this method 2. Now here within the second bracket only the y integration will happen, keeping x constant. So this is x square constant, x square y, 3x constant, and y square, that means y cube by 3. So 3 cancels out and we are left with x y cube. Okay. Then after putting the upper and lower limit, we have 2x square plus 8x. See, there is no y part here. If there will be any y part, then any step or anything I have mistaken. Since there is no y part, so I have done the right thing. This become 2 by 3 x cube and this become 8 by 2 x square. That means 8 by 2 means 4 x square. After putting the limits, this is 14 by 3. See, whether I choose the x way or the y way, in both the methods the result is same, 14 by 3. You can choose whatever you want. Depending upon the mathematics, you can choose any one. Both are correct and both are easy because the limits are independent limits. Now, before I further proceed, if you are new to my channel, then please like and subscribe, and yes, of course, don't forget to hit the notification bell for future notifications. Now, before I proceed to any more complex mathematics, you have to know some concepts. Like in your coordinate geometry, 2D coordinate geometry, you are familiar with this one. This is plus y, this is minus y, this is plus x, this is minus x. So they are what? They are called quadrants. This is first quadrant, second quadrant, third quadrant, fourth quadrant. Depending upon the signs of the variables, this is plus plus, that means x plus, y plus. This is plus minus, that means x is plus but y is minus. Third quadrant is minus minus, that means both the variables are minus. And fourth quadrant have minus plus, that is x is minus and y is positive. Actually, you have to know one more thing, the extended form of this thing. The extended form of this quadrant is called octant. See, this is a 2D implementation. Now, if we expand this into 3D, the picture becomes quite like this one. First of all, my drawing is not so good, so please cooperate with that. So this is the 3-dimensional picture of this one. This is the 2-dimensional picture and this is the 3-dimensional picture. This is the third axis, z axis. This is the x, of course positive. This is positive y, this is negative y, this is negative x, and this is negative z. Now, what is an octant? An octant is one of the 8 divisions of a Euclidean 3-dimensional coordinate system. Now see, this is also an Euclidean coordinate system but in 2D. This is a Euclidean coordinate system in 3D, and the whole cube can be divided into 8 parts, like this one, this one, this one, this one, and the below 4 parts. I have indicated this plane as green, like parallel to x. This plane along y axis, this is purple, and parallel to xy plane, this is the red plane. Just to differentiate between 8 small cubics. Now, the 3-dimensional cube can be easily divided into 8 small cubes. See, this one, this small cube is your conventional 3-dimensional space. We are familiar with this plus x, this plus z, and this plus y. This is called first octant. So this small cube is one of the part of the 8 octants where all the coordinates are positive, x positive, y positive, and z positive. This is called first octant. In the second octant, you see, Z is positive, Y is positive, but X is not. So it is minus plus plus. This is called second octant. In the third octant, in this cube, Y is negative, X is negative, only Z is positive, and that's why it is minus minus plus. For the fourth octant or this fourth small cube, here minus Y but plus X and plus Z. So plus minus plus. This is the upper half. Since we have a negative Z coordinate also, we can have similar four small cubes in the lower half. Now here I have not used, it is the conventional method. The conventional method is to use the right hand rule in the counterclockwise direction. Okay, so this is 1, this is 2, this is 3, this is 4. Similarly, the small cube below 1 is 5. The small cube below second octant is 6. Small cube below third octant is 7. And below 4 it is 8. Respective coordinate signs are given here. Only the 7th octant remain invisible to your eye. Actually in 2D, 3D representation is quite tough. So for our eyes, 7th octant is invisible, but from the notations we can easily infer about the signs of the variables. In the 7th octant, X is positive, X is negative, Y is negative, and obviously Z is also negative. So in 7th octant, that is minus minus minus. I hope this picture can give you a brief introduction about the octant. Why we are so concerned about these octants? Because in 3D geometry, surface can be drawn over 3D space. Suppose we have a sphere. So we have 8 octants because the center of the sphere is O. So we have plus Z, minus Z, plus X, minus X, plus Y and minus Y. So if there is any mathematics covering the whole surface of the sphere, then we have to work with the 8 octants. And for surface integrals, we deal with the projections. Generally, in your examination, questions will be asked about this first octant. Why? Because this is the most simplest one. Here, X, Y, Z are positive. But for some cases, 1, 2 or more than 3, 4 octants may be involved. So, this concept of octant is very important for the visualization of the surface. Okay. Hope you have understood the visualization. Now we can proceed to the further problems. Evaluate surface integral a dot n cap ds over the surface 2x plus y equal to 6 in the first octant, cut off by the plane z equals to 4. Given a equals to this one. So first things first, we have to imagine and also draw the surface 2x plus y equal to 6 cut off by the plane z equals to 4. So 2x plus y equal to 6, that means x by 3 plus y by 6 equals to 1. So it will cut x axis at 3 unit, y axis at 6 unit and z axis at 4 unit. See, this A, B, C, D, A. This is called this A, B, C, D, A is called this x by 3 plus y by 6 equals to one surface. Now this purple surface is the z equals to 4. So this is cut off here. Otherwise this surface can go on like this and be on the laptop screen. Now we are left with two projections. One projection I have already shown here, and the other projection would be at the xz surface. This projection is on the yz surface. See the green spot? This green box is the projection of the surface. This is the yellow box. This yellow box actually resides over this A, B, C, D, A. This surface. This x by 3 plus y by 6 equals to one surface. This is the small portion of this surface. Okay, and the projection of this surface can be anywhere. Can be on the yz plane, on the xz plane. Okay, so you have to choose which projection you are with. Now why I am telling about the projection, because this is the projection. From the concept of dot product, you all know that A dot B means the projection of A over B. So A dot n cap ds means the surface projection over what? Over any of the surfaces, xz, yz or xy. For this case, the two probable projections are at yz and at xz plane. Now I have taken the projection along the yz plane. So A dot n cap becomes A dot n cap ds equal to dy dz, yz plane, which is dy dz, and n cap dot I. So we are left with A dot n cap, value of n cap, dy dz, and n cap dot I cap. Now what is the n cap? N cap is the direction of this surface, this elementary surface of the ABCDA surface. Okay. Now, how to determine the n cap? This is a general method. You have to let phi equals to 2x plus y minus 6. How? This is put 6 in the LHS part. So it's phi equal to 2x plus y minus 6. Now what is n cap? N cap is the unit normal along this phi. What is the general form of unit normal? Grad phi by mod of grad phi, because grad phi is along the normal direction and unit normal means divided by the value of grad phi. Here grad phi equals to I cap plus j cap and the root is root phi. So n dot my mistake, that must be n cap. I'm very sorry. So n cap dot I cap equals to 2 by root phi. See I cap, so 2 by root phi. So we have n cap dot I cap. Now I can easily determine A dot n cap. Now what is A? I cap y plus j cap 2x minus k cap 2z. So what is A dot n cap? Y into 2 by root phi plus 2x into 1 by root phi. So this is our A dot n cap. This is dy dz, and n cap dot I cap means 2 by root 5. So after necessary simplification, we have x plus y dy dz. Now see, there is one problem. This x. Why this is the problem? Because we are doing our projection on the yz plane. So we are left with two variables, y and z. But A has component in three directions. So there may be a x component in our math. Yes, there is an x component. We have to replace this x by y and z. How? 2x plus y equal to 6. So x equal to 6 minus y by 2. Okay, so we can replace this x like 6 minus y by 2. And the value of x plus y is 6 plus y by 2. Clear? In any type of surface integral, you face this type of problem, then remember to simplify the odd variable or to replace the odd variable with the working variables. These are your working variable y and z. This is the odd variable. Okay, so you have to replace this variable with your working variable. So we are left with value of x plus y equal to 6 plus y by 2. This is dy and this is dz. Now the value of the upper and lower limit. How I can write this? See, the first octant cut off by the plane z equals to 4. So z can vary from 0 to 4. That's why z is varied over 0 to 4. There is no x component. Put x equals to 0 here. So we are left with y equal to 6. So y can vary from 0 to 6. Suppose we deal with the projection on xz plane. Then our working variable will be dx dz, x and z. Then you have to replace the y components with x and z. Then you will put y equals to 0 and x equals to 3. So the limit of x in that case will be from 0 to 3. Clear? Put 0 over the variable which is not present in your expression. Here x is not present, so we can put x equals to 0 to determine the limit of y. What if y will be absent? Then we put y equals to 0 to get the lower and upper limit of x. Clear? Now this is a very simple surface integral. You have already done it in your first question. After necessary calculations, we can have 108 is the answer. Now I have done the whole operation taking the projection on yz plane. Remember, you can have the projection on the xz plane also. In that case, this thing a dot n cap ds becomes a dot n cap dx dz by n dot j cap. Okay, you can check your answer for the projection on xz plane. Now for our third question, evaluate the surface integral where a is given and s is the part of the plane 2x plus 3y plus 6z equals to 12, which is located in the first octant. This line is very important. In the first octant. So x is positive, y is positive, z is positive. Everything is okay, and we are dealing with the most simplified format of surface integral. First, the visualization of this surface. For that, we can have x by 6 plus y by 4 plus z by 2 equals to 1. So this surface will cut at the x-axis by 6 unit, on the y-axis by 4 unit, on the z-axis by 2 unit. Remember, you have to imagine or you have to draw the surface in order to get the proper projection surface. It's for your benefit. Till you do not draw the surface, you cannot visualize the projection surface. Okay, so drawing of the surface is very important, but while drawing the surface you have to remember these cutoff points. Okay, there is no hard and fast rule that the surface will be a perfect representation of this equation. Okay, but you have to remember that the cutting point of z-axis will be 2, the cutting point of y-axis will be 4, cutting point at x-axis will be 6. So this is the representation of or my visualization of the surface. Now see, this is 6, this is 2, this is 4. This is not actually accurate, but this 4 unit looks more or less twice the 2, and this 6 unit looks quite as well thrice the 2 unit. Now here you have 3 projection surfaces to deal with. I have done the projection on xz plane. Okay, you can have the projection on this lower plane, that is xy plane, and the plane to the right side, that is yz plane. So you are free to have any projection at any surface. Since we are dealing with first octant, all the coordinates are positive, so we are actually the within the first small cube of the octant. Now a dot n cap ds can be rewritten as a dot n cap. Since the projection, this is this red one, red small is the projection of the blue one. Both are elementary surfaces. The blue one is the elementary surface of this one, this surface, and the red one is its projection onto the xz plane. Since it is projected along xz plane, ds can be written as dx dz by n dot j. J is the surface of the along the y, and n is the surface along the blue one, actually unit normal. Now if the projection were onto the xy plane, this thing will be written as dx dy by n cap mod of n cap dot k cap. Clear? And for the yz plane, we can write ds as dy dz by mod of n cap dot I cap. Clear? Now we have to derive and evaluate the each part of the integration. First, n cap. So phi is what? Phi is 2x plus 3y plus 6z minus 12. This is our phi. N cap grad phi by mod of grad phi, that becomes 2y cap plus 3j cap plus 6k cap by 7. Now the value of n dot j, that is 3 by 7. So the mod of n dot j will also be 3 by 7. If somehow say this n cap becomes 2i cap minus 3j cap plus 6k cap by 7. So what will the value of n dot j? Minus 3 by 7. Then the mod of n dot j becomes 3 by 7. Since it is positive now, so the mod is also positive. And this dx dz by n dot j cap mod becomes 7 dx dz by 3. Now the a dot n cap. See our a is here and our n cap is here. So you can easily check the dot product like this one. Now we have rewritten our y as 12 minus 2x minus 6z. Actually there are lots of step jumps here. The actual the first you get 36z minus 36 plus 18y, and this y is now replaced by 12 minus 2x minus 6z from this expression. Okay, so after calculation we are left with 36 minus 12x by 7. See, we are left with dx dz. Y is unavailable here, so we have to replace y by our working variables. Yeah. Now a dot n cap has this value, dx dz has its own value, dx dz by n cap dot j cap mod, that is 7 dx dz by 3, mod of n dot n cap dot j cap 3 by 7. So after putting all the values, we have this is dx and this is 12 minus 4x dz. Now these variables are dependent. Why? Because see, there is no such cut off by something plain or given lower and upper values of the variables. So you have to determine the variables, like y is unavailable or y is not present here. So put y equals to 0. We have 2x plus 6z equals to 12, like 2x plus 6z equal to 12. From there I have replaced the z by x. Yes, you can replace the x by z also. For that case the limits will be changed. Now z, the limit of z is 0 to 6 minus x by 3. Now for further, put z equals to 0. So we are left with 2x equals to 12, then x equals to 6. So the limit of x is 0 to 6. Clear? I repeat this one more time. Since y is not present here, so we can drop y by putting y equals to 0. Then we have 2x plus 6z equals to 12, z equals to 6 minus x by 3. So z varies from 0 to 6 minus x by 3 first. Then we have to drop the z also. Putting z equals to 0, we have 2x equals to 12, that is x equals to 6. So x will vary from 0 to 6. Suppose you are dealing with a projection on this xy plane, then you have to drop z first, then any one of the variables. Yes, you can do first x then z also. For that these limits will be changed. Okay, you can check that part. Now let's proceed. This become 12z and this become 4xz. Putting the values of upper and lower limit, we are left with 4x square minus 36x plus 72 dx, x equals 0 to 6, and our final answer is 24. This is very simple integral. You can do it by your. Now, what is the most important factor? The most important factor is the projection. See, I have dealt with xz plane projection. You can have yz plane projection. You also have the provision xy plane projection here. You can check there by taking any of these two projections whether 24 is right or wrong. You can check that. That's your homework too. Now let's proceed to our next question. F is given. Now evaluate del cross F dot n cap ds, where S is the surface of the sphere, this one, above the xy plane. See, there is no octant given, only above the xy plane. You can have the visualization of this surface like this one. See, this is the half the surface, hemisphere, and this hemisphere consists of 4 octants. This is our first octant, this is the second octant, this is the third octant, and this is the fourth octant. Means the projection and the integration by projection, the number of integrations are 4 for first octant, for second octant, for third octant, for fourth octant. You have to evaluate the integrations separately and then add them for this whole hemisphere. Quite tough. Yes, I have told you previously that in some cases you may face the whole surface or this type of half surface cases. So you can take on the projection of on xy plane or in any other planes. In that case you have to evaluate 4 separate integrals. One of them is shown here, but there are some other methods too. Imagine or visualize this surface like this using the spherical polar coordinates. This is our elementary area, and what is the direction of that elementary area? It is along the r cap. Why? Because a surface always have direction. And what is the outward direction? The outward direction is the positive direction. So what is the outward direction? Along the r cap. See, r is from center to surface. So r cap is also in outward direction. Now, a surface always have 2 directions. Like this is the more bigger part. Now this has 2 directions, along this one and along towards the center. But if nothing is given which direction is to take, we always deal with the positive direction. And the positive direction is what? The outward direction. That is along the r cap. If any math contains a language like this, that the direction of the surface is towards the center, then the n cap is towards the minus r cap. But for here it is plus r cap. Okay, so we will deal with n cap equal to r cap now. But this r cap is along the general direction vector, general spherical direction vector. This is not only the radius of the sphere, this is the general position vector r in spherical polar coordinates. What are the coordinates? X equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. Now I cannot explain how these coordinates are formed or how these Cartesian coordinates can be transformed into spherical coordinates here. For these transformations, I will make a separate video. But for now, you have to either cram it, or I know that you are quite familiar with this because these are heavily used in mechanics and your 11-12 standard too. Now, for a spherical polar coordinate, this general vector r can be written as I cap x plus j cap y plus k cap z. So, what is x? R sin theta cos phi. What is y? R sin theta sin phi. What is z? R cos theta. Now, this is the general position vector. You have to determine the r cap. Remember one thing. Don't misunderstand this r with this r. This r is the general position vector, but this r is the value of the radius of the sphere. I repeat, do not misunderstand this r with this r. This r is the general displacement vector, whereas this r is the radius of this sphere. Clear? Now we have to determine the r cap. This is our n cap. So what is r cap? Del r by mod of del r. It is like the one-dimensional representation of grad phi by mod of grad phi. This is the value of r cap. Now you can remember r cap directly by a matrix. So this is the transformation matrix. This is the transformation matrix. R cap, theta cap, phi cap matrix. This one to I cap, j cap, k cap. Now I cannot also explain how this matrix is formed because spherical polar coordinates and cylindrical polar coordinates are two separate topics, and if I am starting the explanations here, then this will be a hour or 2 hour long lecture. So for cylindrical and spherical polar coordinates I shall make separate video, but for now you have to remember this one, or you can evaluate the unit vector by the general method. Whichever is simple to you, you can do, but you have to determine the r cap, and ds equals to a square sin theta d theta d phi. What is a? Actually this is the general transformation, or this is the general transformation coordinates. See, x plus square plus y square plus z square equal to a square. So our radius is a here. That's why ds equal to a square sin theta d phi. Now again you may ask, how can you write ds equal to a square sin theta d phi? Again I have to tell you that I cannot explain it here because the whole system, the whole expressions are in the chapter or in the topic of spherical polar coordinates, which I can't explain here. Now you can have the provision to work with this projection type Cartesian coordinate system. Okay, if this thing is way too tough for you, then you can go for that, but you have to deal with 4 separate integrations for that. That will be a tough one for calculation, and this one will be a simple one, as we have to only visualize what is the direction of n cap. N cap may have the direction of theta cap or phi cap. Only you have to visualize the whole scenario based upon your question. Okay, so for our question, R cap is the outward normal is the N cap. Okay, so what is del cross F? Del cross F is very easy. First use Cartesian coordinate system, then convert into spherical system. Now we have del cross F dot N cap ds. See, we already have del cross F, N cap and ds. Putting the all values here, we can simplify the whole thing like a cube sin theta d theta d phi minus 3a cube sin theta cos square theta d theta d phi. Now the integration is as follows. You all know that the values of the theta and phi are generally 0 to pi and 0 to 2 pi. But since this is a half sphere, hemisphere, the value will be theta equals to 0 to pi by 2 only. For the whole sphere, it is 0 to pi. For the half sphere, it is 0 to pi by 2. While dealing with cylindrical and spherical polar coordinates, be very cautious about the limits. Actually, for entire integrations, you have to be very cautious about the limits because they are the key vital points of your answer. Now, this is our integration. We can divide this into two parts. First one like a cube, then 0 to 2 pi d phi, 0 to pi by 2 sin theta d theta, very easy. Second one is 3a cube, pi equal to 0 to 2 pi d phi, 3 to 0 to pi by 2. Now we can rewrite this sin theta cos square theta d theta as cos square theta d of cos theta. Now see, d of cos theta means minus of sin theta d theta. That's why this minus become positive here. Actually there are 2 or 3 step jumps here. This thing can be rewritten as cos square theta d of cos theta, which invites another negative sign, then that negative and this negative becomes positive. Now see, this is 2 pi, this is minus cos theta with limits, this is also 2 pi, and this thing becomes like x squared dx, that is x cube by 3. So cos cube theta by 3, upon putting the limits we have 0. Okay, now you can recheck this value by Cartesian coordinate system. You can check, you can do 4 separate integrations with 4 different projections and then add them. See what will happen. That's it, up to you. Now we shall proceed to our 5th question. Evaluate this integral where a is given and the most important part, S is the surface of the cylinder, x square plus y square equals 16, included in the first octant between z equals to 0 to z equals to 5. So the simplest way, first octant. How can you visualize this? This is the Cartesian coordinate system representation where this solid line is in the first octant. So you are free to have the projections on, like myself, in xz or in yz. Okay, but we can have the provision here also using the cylindrical polar coordinate system. See, actually I do not prefer taking projection type problems in cylindrical or spherical coordinate system because the other way, that is the polar way, is way more better and way more simple to see for yourself. This is the visualization of in cylindrical coordinate system. So what is the direction of this elementary surface? Along the r cap, which is outward normal. This is our n cap. N cap equal to r cap. You can imagine this surface like this. This is our r. This r is a general vector, r vector. This r is towards the r cap. This is the outward normal. So our n cap is along r cap. Now this is the general cylindrical coordinate transformation equations. X equal to r cos phi, y equal to r sin phi, z equals to z. We shall use this in our question, where this r is the radius of this sphere, cylinder. X square plus y square equal to 16. That means 4 square. So r equals to 4 here. Now let's write the general displacement vector as this one, where this r equals to 4. I repeat, this r equals to 4 and this r vector is the general displacement vector. Don't get confused there. N cap equals to r cap as usual, and we have ds equal to r d phi dz, where r equals to 4, so 4 d phi dz. Now you can remember this transformation matrix because you can have the provision in any mathematics that n cap is along the phi cap, so you can easily determine what is the phi cap here by this transformation matrix. But these equations, this matrix and this ds, how they are like this? Again, I am telling you, I am not gonna explain this in this lecture. I shall make a separate video for cylindrical coordinate systems also. Now we have a dot n cap ds like this. See, our a, where z equals to z, x equals to r cos phi, y equals to r sin phi. So you have to simplify them in our own cylindrical polar coordinate system. Okay, and the result is this thing. See, only phi and z is given, no other variable is here. Okay, so we are right. Now the integration can be written, can be divided into z cos phi 4 d phi dz and is 4 sin phi cos phi 4 d phi dz. The first one is very easy. The second one is also easy, but there is a small trick. Either you can have 2 sin phi cos phi equal to cos 2 phi, this type of integration, or you can write this cos phi like sin phi d sin. Now solving an equation is up to you. You can use your general trigonometry equation. Sin phi cos phi means sin 2 phi by 2, or you can use this type of transformation. It's up to you. No one can teach you how to solve an integration. I can only teach you what is the way of the solving of an integration. But you have to choose the path for yourself, because there are several paths. See, there are Cartesian coordinate path, cylindrical coordinate path. I can only give you a way which path to use. It's up to you whether you can use the Cartesian path or the cylindrical path. Now the value of the integration is 90. It's up to you. You can check whether I am right or wrong. How? Now you can use this one. See, this is not a whole surface case. This is limited in first octant. So you are also limited with only one integration. Like the second question, you can recheck the value of this integration onto taking the projection along xz plane or in the yz plane. This is also your homework to recheck this whole mathematics in Cartesian coordinate system. Okay, so this is the end of our today's discussion. Thanks for watching, guys. See you soon.